Okay, we're going to look at the hardest part of this 2017 number 1 question. That's part D. Water is being pumped into the tank. When the height of the water is 5 feet, the height is increasing at a rate of 0.26 foot per minute. Using the model from part C, find the rate at which the volume of water is changing with respect to time when the height of the water is at 5 feet. So we're supposed to be using the model in part C, in which they tell us we have the cross-sectional area is given by this function f of h. All right, so we're asked to find the rate at which the volume of the water is changing with respect to time. So that means we're trying to find dV dt. Okay, we're given that we're going to find dV dt when the height is 5, the height of the water is 5. And we're also told that dH dt is equal to 26 hundredths of a foot per minute. That's the rate at which the height is changing. So the volume has to be found, in some type of an equation for the volume has to be found. If we're trying to find dV dt, we need the volume to be able to take a volume equation to take the derivative of. Well, we've already done earlier in the part, so this part should be okay. The volume is going to be the integral from 0 to h of f of x dx. Again, f of x is the cross-sectional area, dx is the thickness, like we showed up here, and we take the integral from 0 to h as those stack up for the entire height, however high you're going, h. Well, we have to take the derivative of that. So we're going to take the derivative with respect to h. That's the only thing we can do it, because our function is, this is v of h. And the derivative is going to be dv dh is going to be the fundamental theorem of calculus. We just plug the h into the function, and dv dh is f of h. Now, this is the huge part right here, this Leibniz notation. We're trying to find dV dt. We were given dH dt, so you've got to come up with an equation that uses dH dt when we're trying to find dV dt. And so that means dV dt will equal dV dH times dH dt, where the dH's cancel. So at the very beginning of this problem, if you were confused and you didn't know what to do, and you were told this dH dt, and you're trying to find dV dt, you would say, gosh, how can I relate those things together? And so then you should be able to come up with this, that dV dt would be dV dH times dH dt. And then you would know you need to take this derivative with respect to h, because you need a dV dH. Okay, so now that we have this, we're trying to do this at the time the height is 5, so dV dt when the height is 5 equals dV dH times dH dt when the height is 5. And so we already know that dH dt is 0.26, but what's dV dH? Well, we know that dV dH is f of h, and when h is 5, f of 5 is 6.517 by plugging the 5 into this equation, f of h. So we're pretty much done. dV dt is dV dH, which is 6.517 times dH dt, which is 0.26. You plug that in your calculator, you get 1.694, and that'll be cubic feet per minute. The volume of water is increasing 1.694 cubic feet per minute when the height is 5 feet. 3 points for part D. You get 2 points for this relationship dV dt, and you get 1 point.